लाइब्रेरी के अपनी कोचिंग के अपने हम कैसे बताए। जो पहाड़ पे अच्छा हो।
Hi everyone, am I audible? Please confirm in the chat if you are not able to hear me. So last session we discussed about the overview of cloud computing and what we're gonna see in this semester. And we started with context session one, and we saw a few definitions on cloud computing and the list of models and deployment models, service models, etc. And we even started covered till some characteristics. So we continue from there, and we'll get into module 2 as well. That is your context session 2. So once again, welcome you all for context session 2. So initial stages, it will be a little bit of theory part where you need to have a wide understanding about what are the characteristics, what are the service models, what are the deployment models that are available, and how it is being utilized. So we stopped, I think, in the automation where we saw self-configuration, self-healing, self-optimization, and self-protection. Suppose that so all these things comes under manageability and interoperability. The second part is system monitoring. So few would have been managing the monitoring using various tools like right. Similarly, this is also a process like all the resources are present somewhere else, right? Even if you take Azure, you can have your own native monitoring for the workloads we have launched on the Azure platform. Okay, so you have to collect and store data, or else if you are into shared managed services with a third party vendor, what he or what they will do is they will use tools like Site 24/7 or else the Nagios. Various monitoring tools are available in the market, Science Logic, etc. So using that, they will be monitoring the workloads which is being hosted by the customer on the cloud infra. That provision is provided to you. Either you can do an integration or else you can have the native monitoring tools on Azure. You can set up Azure using Azure Monitor and you can store those logs in Log Analytics workspace. Not only Azure, you can also do in other cloud providers as well. Okay. So what can be monitored? You can see uh, or what should be monitored in a cloud infra. So from the cloud point of view, from the cloud infrastructure point of view, you need to monitor physical and virtual hardware state and the performance metrics. Okay. It is not that we do monitoring. The data center should also be monitored. That is what is the understanding. One second. Okay. So resource performance metrics. Let's say uh, your CPU, the memory, and your storage. So everything would be consolidated yeah, using consolidation as well. You need to monitor all these things. Your system logs, various are there, and anything more than that, you need to see which is your billing. So billing system is the most important part of the cloud. So user has to pay so for whatever they use. Okay. So cloud provider must determine, okay, what are the list of services they have launched for the customer usage, and what is the pricing for that? And those based on those records, let's say you will be using for 730 hours or lesser than that. For that, the respective for a month, what will be the billing? 1 second. Hello, sir. Okay, and so if you see for which resource, what kind of billing, all these details the cloud provider should already keep in place so that the users will understand and see how to monitor and reduce the cost. Let's say if you have a VM, few customers, what they do is to reduce cost, they'll go to reserved instances or else they will do auto start stop, okay, on their infrastructure. So that to reduce the number of working hours, let's say 730 hours is being billed. Okay, so based on the usage to do optimization. So 730 hours, like if a machine runs 24 hours and almost like 29, what is that? 30 days, okay, the 31 days, like together, consolidated, they'll run for 30. So to reduce that, okay, what the customers will do is they will schedule auto start stop so that when the machine is not being accessed, it will be the server will go to downstate. And early morning during the business hour or before the business hour, it will be shut. Okay, so these things will has to be automatically calculated and such things to be paid. Next topic is performance optimization. Here we will see how the performance is managed on a cloud infrastructure and how optimization is also taken care. So it requires three things. One is parallel processing. So you need to have high performance. Okay, so how the performance metrics has been guaranteed. Okay, so if you see uh, the cloud or the application performance will be guaranteed on the cloud because it's a shared infrastructure. So if you see cloud providers, they will use all these, they have all underlying resources, even though how they optimize or how they schedule it and how they share it across all the other customers, okay, whom they support. So to keep it on priority, like to achieve this on priority, they use all these three you can see down. That is your, they use parallel computing, okay, and load balancing and job scheduling. So parallel processing is like uh, you'll run you the customers or multiple customers can run their jobs, okay, simultaneously. Okay, so if they have larger problem, they can divide into smaller ones. That's what big data or Hadoop, all these infrastructures, they work on cloud. Okay, if you build a microservices architecture in AKS, okay, those are like clusters and they will scale out whenever the load is increasing automatically without the administrator or the customer intervention. The same thing is applied for this thing also. That is your infrastructure also. For example, you have a server. Your US, you have two servers, okay, which is serving your application. How two servers can be utilized at the same time? That is what is parallelism. So different levels of parallelism. We have bit level parallelism, which is hardware level parallelism. So in all these instruction level, data level, okay, all are instructional and bit level, hardware level parallelism, and data level and task level are the software level parallelism. So hardware approaches, as you said, like you can use multi-core processors. You have symmetric multiprocessors. You have general GPUs. Yeah, for graphic processing alone, you have separate processor. You have vector processor. You have distributed computing, where you have cluster and grid computing, and some of the software approaches as well. So what is load balancing? Load balancing, from the name itself, you can understand like it is uh, managing the load or distributing the load evenly. Okay. So distributing the workload, okay, across two or more computers or network links, CPUs, hard drives, okay, whatever resources you have to load balance it. Okay, so that your resource utilization will be optimized and you can maximize. If you do that, you can maximize the throughput. Let's say you have two computers, okay, and you are only processing all your inputs on the first computer and not to the second. So that the second is underutilized. So you need to utilize it, okay, various times or on workloads. What is that? When you have a larger workload, but you're pushing your first computer itself to or first server to do that job. If you share and give it only, you can minimize the response time and you can avoid overloading and so that what are the benefits you get is mm, you get high throughput, okay, and resource utilization can also be improvised. So don't think this is a different diagram, okay. It is also like opposite if you make one more person to sit so they can survive, okay, or else it is like to some extent you have to do this load balancing. So why load balancing is important is you need to improve resource utilization, system performance, and energy efficiency. So next is job scheduling. So scheduler is nothing but, uh, for example, let's say you have a processor. Okay, let's say two processors in place. This is already in place, like how the processor is being utilized. Okay, how the jobs are being scheduled, how they are kept in queue, what kind of techniques they use, so that at the background, the CPU will be will be utilized properly without underutilizing it. Okay, so if you see, the computation can process any kind of information or any instruction you give it to the system. So like what task you're doing, you need to process the dependency, okay, of the complex jobs. And you should have all how to approach such things is you need to have predefined workflow and you need to have a systematic configuration. So even if you take your system is also doing job shooting, your operating system does that. Similar way in cloud also should be taken care. Next is accessibility and portability. So how you access the workloads and how, for example, from anywhere, anytime you need to access. That is what anytime, anywhere, anyone can access the cloud. So accessibility is nothing but how you describe, okay, how you access a product or a device or a service, okay. So in various ways and by people as possible, okay. It should be easy as they need to access it. What is service portability? So you need to access a service, okay, uh, using any device, let's say from mobile or from laptop, from desktop, okay, you need to what is that use it from anywhere, and it should dynamically adapt, okay, on various resource, whatever resource you have, let's say on your mobile device, on your tablet, on your laptop, on a on a low end machine. So that's what through browser they're giving all your cloud resources. So that is uniform access, how to achieve these properties and thin clients. Uniform access is any browser you use, you can be able to access the what is that, the cloud's website or the user interface. So you can see various websites available in day, and all those using those browsers, you can take the services delivered, and you can use those web interface to through internet, and you can access any cloud website. Okay, that is uniform access. And next is thin client. Thin client is a computer. Okay. I don't know how you use it in your workplace. They will give you a desktop. Okay, thin client will not have a what is that? It will look a small. Okay, uh, and it doesn't. It is not a hard or a heavy computer. Okay, it is not a traditional computer device. Like it will be having a small piece of a fat thin client. Okay, so it has some cheap client hardware and so it provides several client sessions. Okay, you can just log into to these servers by using the IP address, or if your cloud is hosted through the web link, you can access through the web link. Even your thin client or it doesn't need a strong operating system because you can use a Ubuntu hardware and you can just what is that log in through browser to any cloud resource. So as I say, diversity of end devices, you could see end user access cloud services like they have via plenty of electronic devices, even it includes phone and smart TV. So what we gain, what are the benefits from the cloud? So this brings many benefits. Okay, so you can see for the market and enterprises, you have the initial investments is totally reduced. Sorry. And it reduces the capital expenditure. That is, if you want to build a data center for your application to be hosted, it gives you a huge amount of cost or in the expenditure at the earlier stage of the business. So this improves industrial specialization and it improves this resource utilization. And for end users and individuals, so it uses reducing local computing power. Let's say I have a laptop, it doesn't require an i5 or an i7 processor. Okay, it requires a decent, even you can buy an AMD Ryzen equivalent to i3 or i5, whatever. Okay, so minimal computing power is required. And it also reduces local storage power. Let's say it doesn't require, what is that, a 256 GB of SSD or more than. So you can just have a minimal C drive so that your operating system on top of that. And then you can access a browser is pretty much uh, helpful for you to access the cloud infra. And variety of thin client devices you can use. So still more in detail we are going to see about each and every point. So reduced and reduces initial investment. So if you take the traditional process of enterprises to initiate business, okay, if I'm getting into business, even if you see in cloud itself, many programs they are having, like you have Microsoft is providing program for startup. So MFS, so Microsoft for startups, they will give $12,000 per month. Okay, so that every month they can, if they are within the budget, okay, they have that credit. It is like a credit and they can bring their business. When they mature, they move to CSP program, like partner provided cloud, and the billing will start from then. And so until you are mature and your business is growing, Microsoft is providing funding for the entrepreneurs. Okay, so there isn't any cost involved, right? If you see, uh, they need to purchase and deploy IT infrastructure. They need to install and test the software system. I don't know whether you can check the cost. If you see processor based cost, you need to buy. For example, you're going to uh, have a data center. So two kinds of editions you have in software also. If you want to buy server license 2022, okay, or 2019 or 2016, you will be buying it for the number of processors, okay, where the operating system is going to be installed. Okay, for example, you have a server and it is having two processor and the cores. Okay, processor cores, if it is 2 core or 4 core or 16 core, for that you need to buy the license. Okay, and for that also cost is involved. That's what I told you, to deploy IT infrastructure on a data center. Okay, for you, okay, you need to have hardware, you need to have the licenses. So without license, you will not be able to run your show. So, and then you need to design and develop enterprise specific business service. So this data center, I'm going to serve this much of customer. Okay, so what kind of service you're going to give it to your clients? So what are the drawbacks in this approaches? The survey analysis and estimation may not be 100% correct. Okay, it may fail. And the infrastructure deployment is time consuming, because if you buy a rack server and you need to manage the rate controller, and then you need to process it, a lot of things better. Okay, so if you see enterprises or any major business organization, they should take risk of wrong investment. Next is the initiate business with cloud computing services. So if you see the survey and analysis they do in the industry and market, and they can choose any cloud provider. Let's say we have a lot of providers, right? Even third-party providers is also available. The major players are like Azure, AWS, GCP, etc. So you can design and develop business service based upon the cloud infra. Like if you have certain things which suits the cloud infrastructure, you can use that pretty much. And then you can also announce the business service to clients. So some of the benefits you can see, you don't require your own infrastructure. Okay, enterprise can develop and deploy business service in short time. Only design deployment time is needed. If the architecture is ready, your application is going to run on the architecture, the infrastructure architecture. You can pretty well start the business in just in like 3 months duration. You can test it across, and you can also reduce the business loss on wrong investments. So you can see what does how cloud computing is being achieved. So you can see investment risk, infrastructure, and time duration. So you can differentiate yourself like from tradition versus the cloud. So in tradition, it requires enterprise, they take risk. Okay, in cloud, it reduces the risk. And if you see the infrastructure, they own the infrastructure. Okay, they have to buy. You need to set up a data center rack and data center space with proper cooling. And if it is a modular data center, you want to buy modular data center racks and the internet speed. Uh, so for that, for everything you should keep default. What is that? Mm. So keep things ready. And if you take time duration, it takes long deployment time, because a lot of things, whether if you don't have a data center at all, you need to check up a space, and you need to buy racks, you need to buy internet, you need to buy cooling, many UPS power supply, a lot of things with it. Whereas it is just business ready. Next is reduce capital expenditure. We will talk a little about capital expenditure. So capital expenditure in the sense, two kinds of expenditures will be there if you take any organization. It could be IT or non-IT. Okay. So they are going to run business out of building some products, right? So every enterprise, okay, they should establish their own IT department first for local as well as the servers. Local in this sense for their end devices. For servers or where their applications are loaded, let's say that they should buy servers and they need to do. So this IT department, so what they have to handle, you can see over here. 1 second. Hello. We'll be back in 2 minutes, guys. Please wait. Hey guys, I'm back. So if you see, so IT department, they need to administrate the hardware and software. They need to manage, and they need to take regular backup and checkpoint for the recovery point. And they need to buy new infrastructure and eliminate the outdated one. Let's say if you take the hardware, you cannot use more than 3 years. Okay, the blade servers. You see, I don't know whether you are part of the data center. Okay, might be part of backup. So in such cases, so um, we have managed a lot of data centers earlier in my career, and I was even part of from the what is that from the deployment and managing backups. Now we are doing it on cloud through an interface like where we had engineers, we made them directly load the tape drives, okay, load and copy TBF data, and then and procurement of new infrastructures as well. So if you see any blade server, it will come for 3 years. For software, you have two kinds of license, perpetual and cloud-based license. Now it has been uh, widely used. Okay, so and then standby for any unexpected IT problems. So we will not know what will happen. We face a lot of challenges with a lot of vendors where we manage data centers. Okay. So we will not know when, if you see, we were managing a publishing domain, okay, where they have the data center. Now we moved them into partially into cloud, and they have. So we will talk about the hybrid data centers, right? So hybrid is nothing but you don't trust on your cloud and all your data. They want to have 7 to 10 years of data retention. Okay. So what are the drawbacks? So huge IT investment, crores and crores of IT investment. If you say uh, you need to buy a server, it will come around 7 to 10 lakhs for a blade server with high end, let's say, uh, two core high end processor, Intel Xeon with 256 GB of RAM, and you can have TBs of data. Okay, in hard drives also, storage also, you have a lot of storage types. Let's say it is not like our what is that hard drives. I don't know whether now you are into the SSD era. Before that, we were using hard drives. Okay, hard drives also has different throughput. You can see all those differences. So hard drive speed is different, and SAS based hard drive speed is different. So SAS is serial attachment kind of a drive. So it is a hard drive, and you have hard drives will have magnetic uh, uh, what is that? So not magnetic, cylindrical disk inside it. Those are hard disk drives. Now they are outdated, and now we have. So how the SSD is also how they are providing standard SSD, premium SSD. Okay, there also you have in what way the data are fetched. Okay. So if you see IT investment is huge, they need to focus on business, but if you see IT investment will be huge. And enterprise, they should take the risk for hardware and software malfunction. So if something goes wrong with the application or the hardware, how they can manage, and they need to replace and update infrastructure, which is also time consuming and risky. Now you can spend 4 crores or 10 crores for your project, and after 3 crores, you need to again do it. So as you say, for risk of hardware and software malfunction on the, if you say you have bought a Dell Enterprise server, okay, a Blade server, and you need to again pay the first year only. It will be free for was full support and hardware replacement. After that, from second year, you need to pay AMC. You need to pay AMC for every server. Let's say 30,000 or 20,000 per server. If you have 10 servers, that itself will come to 2 lakhs. Okay. So it is an additional cost for you to have it, because these servers are enterprise servers, and if something goes wrong immediately, it is not like you can give it for service. The only thing is you can replace it, the RAID controller or whatever random access memory, etc. So coming to capital expenditure, so enterprise, they cannot dismiss the IT department, okay, because they need to store data and they need to monitor. Somewhere or the other, IT will be attached to them. Okay. So if you see, those jobs of IT department, okay, can be achieved by cloud provider. So you can dynamically update. upgrade the hardware or software on a user interface. You can do that. You can change your server configuration. Now you're running your server on 16 core processor. If you want to increase it to 32, you can just like that increase. So how it is done? So you can do dynamic provision and you can deploy infrastructure for enterprise. Okay, enterprise in the sense your business is needed a large core or large volume of data to be processed or stored. You can do that, and you can automatically schedule backups, and you can also check the consistency. In various locations, you can store the backups. And then self-recover from disaster or system malfunction. If you see your machine is hosted on cloud, you see you can just move. Even on a private cloud, we can do that. Okay. Whereas, for example, you have housed a server, and on that server you have installed operating system. On top of that, you have installed what is that? Your application. Now your operating system is giving an issue for you. You will not be able to move your application from that hardware device to another hardware device. Let's say your hardware is going to fail, okay, or else it is intermittently restarting. What you will do? So, but in cloud, you have virtualization. So, virtualization on top of that, you will have VMs or any PaaS service. You can just move those VMs like lift and shift from that virtualized infrastructure to another virtualized host. So, that is called as self-recovery. What are the benefits? So, enterprise can shift the effort to its business focus. And enterprise can reconfigure its IT services in a short period of time. So, enterprises pays to cloud provider, okay, for how many services they have been used, not for everything, right? So for whatever they use, for that only they'll be paid. So now you can see the difference in traditional and with the cloud computing. So business focus needs to own its IT department. It's true. Here, cloud providers takes care of everything. So the underlying infrastructure, etc. Payment, here you need to do full investment, okay? And you need to also take human resource. So whereas here, enterprise pays as the service is used, because enterprise will have cloud administrators. They can take care of everything. So, and then to establish, it takes long duration. Here it is business study. So next is to improve industrial specialization. If you see traditional industry and market, so every enterprise has its own IT department and resource to be managed by themselves, and then they have to take care of the enterprise as well. Drawbacks is IT department is they don't know about what business the enterprise is, right? So it is not the business focus of the enterprise. So IT is different. Now, most of the enterprises do not well maintain their IT resources. They will have less cost, okay, given to them. So, and also they won't care about the expenditures, okay, for optimization with respect to IT resource. So next is collaboration with cloud providers. So if you collaborate with the cloud provider, they will maintain the IT infrastructure for clients. Okay. And these providers they employ experts for managing and administration. And they focus more on providing reliable IT services. Okay. So enterprises, they can just rent those services and they can use it based on the need. So due to which you'll have many benefits, like you'll have industrial specialization will be improved because you're not worrying about the underlying IT. So, and then IT service performance will be optimized, and enterprise can focus on business. So whatever business they are doing, they can focus on that instead of concentrating on IT. And I say IT resource waste will be reduced. Now you can see how this. So here if you see enterprise needs to take care of everything. Here they can focus only on business. Enterprise works on poor manageability because they don't know how to manage IT, because they know only their domain, right? How they know about the IT. If they want to know IT, they need to set up a CTO, they need to set up an architect, multiple architects, lot of things to be enabled. So cloud providers, they apply professional control over everything. So if you see relationship wise, traditionally it is standalone enterprise, whereas if you go and club with cloud, it is a win-win partnership. So if you see traditional industry and market, if you see as we already discussed, like enterprise, they don't care about IT resource utilization. Okay, they'll just spend. But nowadays, even if you're on cloud, you need to concentrate on what resource it is being utilized, and you have to optimize it. That is pretty much easier than doing it on a regular on-premise infrastructure. So enterprise wants their IT without well management, and if you see, they invested on peak demand. Okay, so they will not know when to properly what is that benefit invest on certain things with respect to IT. Some drawbacks are like power and space utilization among enterprises are wasted, and IT resources across enterprise cannot be shared because it is you have a dedicated data center, and for that, what minimum resources are required that should be deployed. And collaboration with cloud providers like so here IT resources are centrally managed and optimized. And with respect to cloud, because cloud providers have their own setup, right? So they build these providers, they build performance optimized hardware. They build a cooling system, consolidated cooling system. So if you see, if you want to build a data center in your office, for that you want to have a separate space and separate cooling. If cooling is having an issue, then your performance will also go down. Okay, so the servers will have sensors, and if the temperature goes beyond that, you need to even monitor temperature. Those things will be automated. We will have a lot of sensors and time sensors as well as a temperature sensor. So the cloud providers will provide. That's what for managing temperature. Even if you would have heard, data centers are submerged in the sea, and data centers are built inside the forest. Okay, where huge number of usually it will be chill, and the rain will frequently come. So based on that only, the data center areas will be geographically filled, and they will consider the geographical issues as well. And if we see, cloud providers will also consider legal policy issues. So you can check the benefits. So now you can see IT resources underutilized most of the time. Okay, and then here it is shared, right? So it improves cloud virtualization is there. So virtualization will give you what is that improvised utilization of IT resource. And if you see the power and cooling system wastage. So because for running a single business, you will be house your infrastructure on a very big data center. So now we have third-party data centers in Chennai also. If you see, SIFI provides, Jio has their own data center. They are also part of data center enterprises, wherein they provide shared infra. And then if you take cloud systems should be global optimized. Okay, so now reducing local power computing. So traditional local computing power requirements. So for example, you need to have your own personal computer, right? You need to buy that, and you need to buy a powerful processor for intensive computing. and you would have large memory and to meet your application requirement and install plenty of applications. So drawbacks is uh, one can hardly replicate the same system environment. Let's say that is really important and it cannot be done. And regularly updates should be done. For example, you all have your laptops and it will be regularly updated through MDM policy, Defender policy. They will push the updates. Okay, but it's your laptop. All these things you need to carry out. And then reinstall all applications. If you reinstall the OS, that is also required. So using cloud computing resources, you can utilize the remote computing power in the cloud. And you need only basic thing. What is that? Internet is required. That is, and cloud applications will automatically upgrade. It won't ask your intervention to upgrade. So now you can see how does the cloud computing achieve this. So user needs to buy powerful hardware if it's a laptop or hardware desktop. Sorry. So your basic hardware to connect to internet is required. As I say, right, you can buy an i3 laptop or even an AMD laptop with browser and internet. And software requirement, you need to install applications in the local environment, like it is not at all required in cloud. And how hard to be portable. Okay, because everywhere you need to have those applications ready. And if you see, it is natively portable. And if you take storage also, like storage means hard drive. So user programs and data files are stored in local devices. User has to back up that on a separate hardware like external hard drive. What are the drawbacks is you may not you may run out of space, right? Okay, that will be there. And even your resource wastage, you'll store only if you buy 100 TB of data and you'll use only 1 TB of data. So it is a resource waste. And data consistency is also hard to maintain between computers. Okay. So as I said, like, you need to sacrifice part of the storage space for data backup, or else you need to buy additional storage. So using cloud, okay, all your files are stored in cloud and the availability is also 100%. So benefits is like you can dynamically allocate storage. You can upgrade the space of your machine. Okay, if you want to extend the drive also, you can do it pretty well. So there isn't any need for you to care about data consistency between computers. Okay, and about data loss due to hardware damage also. So every data will be perfectly stored. So you can access your data from anywhere else from the in the internet. So now you can see the difference, like limited to local disk, maybe underutilized. Okay, here dynamically allocated, you can allocate any number of GBs to your hard drive on the server. And storage consistency, like it is difficulty to maintain and maintain the data consistency. Here you can maintain the data consistency by having policies in place. Here there is no regular user data backup. Here cloud service guarantees that. So various varieties of end devices you can see. So one can connect to internet by personal computer. Okay, so personal computer can deliver reasonable computing power and it cannot perform incentive computation due to power and hardware limitation. Whereas computing power is not portable and small devices can only do small simple task. Okay. So here if you collaborate with the cloud, so devices connect to internet through wireless network and then through web interface they can connect to any resource. and user can access unlimited computing power anywhere. Okay, so they can manage a small device can also be intelligently managed through cloud. So difference is now you can access only through desktop. Here it can you can access from any small device. And a small device intelligence. Okay, if you see functionalities was limited due to the power consumption. Okay, here you can shift those jobs into cloud and then you can wait for results. Okay, and then next is we have covered the different perspectives with respect to cloud and the properties and characteristics and various benefits. Okay, comparing a lot of things. Now we are going to get into service and deployment models. So 3 service models and 4 deployment models. Before that, we'll have a short break. Okay, let's continue. So service models indirectly. So a simple analogy where you just move to a city and you're looking for a place to live. Okay, so you have some options like what is your choice? Like you're gonna build a new house or you want to buy an empty house or to live in a hotel. So if you build a new house, you have full control of everything. Okay. Uh, like your new what you have with what you're gonna have in your new house. Okay, but that's a hard work. And whereas if you buy an empty house, like you can customize some part of the house, but you cannot change the original architecture. And if you live in a hotel, like you have a good idea of like only thing is you can just care and enjoy your life. Okay, nothing you can do with the house except living in it. So we can translate that to the cloud computing as well. So service models like what if you want a IT department? Yeah, so if you see similar to building a new house, you can rent some virtualized infrastructure and build your own IT system among those resources, which may be fully controlled. So technically speaking, you can have a solution like infrastructure as a service. Next is buying an empty house. In previous analogy, okay, like you can directly develop your IT system through one cloud platform. Okay, you don't worry about or care about the lower level resource management. Okay, technically speaking, you can use a platform as a service as a solution. Next is live in a hotel. So you can directly use some existing IT system solutions which were provided by some cloud application provider. Okay, without knowing any detailed technique about where it is hosted or what server it is running, you can just use it as service and you can achieve it. So here you can name it as software as a service solution. Now you can see the difference. So SaaS is you can use the SaaS products like on a web-based application through mobile device or on any business services. Okay, only application you use. Whereas to build that application, you want some softwares, so some development tools. Okay, some runtime environments. Okay, some interfaces. Those are called as PaaS services. Okay, which is platform oriented. Next is your YAS. YAS is where your hardware is given to you. So the interface will give you resource management, how to launch a device or launch a VM, etc. And you need to have a system monitoring interface and resource management interface for that. So under that, you could see you have a network, storage, computing, virtualization, those resources you can use. So first is infrastructure as a service. Okay. So infrastructure in the sense the capability is provided to the customer or consumer. Okay, is to provision processing. That means compute, storage, networks. Okay, and other fundamental computing resources where you can just deploy and run your arbitrary software. Let's say you can install on top of it. Okay, so this includes operating system and application. So you can select a VM and you can ask the VM to get it launched with this OS. That is also available. So the problem, sorry, the thing is like the consumer doesn't manage or control the underlying hardware. Okay, under above it, they can have control over the operating system, storage, deployed applications, and limited control on selected networking components. So example, you can see here like Amazon EC2 or Azure's virtual machine or G Suite's compute, the Google. Yeah. So you can see under the infrastructure, you will have virtualized layer. Below that, you will have computer consolidation, network consolidation, and storage consolidation. On top of that, you will get the you will get the resource management interface and system monitoring interface. Using that, you will be able to pretty well manage things. So like this. So how enabling technique called virtualization. So virtualization and abstraction of logical resources, okay, away from the underlying physical resources. Let's say a traditional stack looks like this. You will have an hardware. On top of that, you will have the operating system. On top of that, you will have multiple applications. Here, under the hardware, on top of the hardware, you can install a hypervisor, okay, which is a virtualization software. So on top of that, you can have multiple operating system, and on top of that, you can have multiple applications. Okay, here right hand side you can see on top of this OS, three OS it has shown, right? Like one can have Windows, one can have Linux, and one can have one more Windows. Now properties supported by virtualization technique. So this is what we studied earlier, right? Like the manageability and interoperability, availability and reliability, and scalability and elasticity. So resource management interface. So this resource management interface, what service it provides? Okay. So several types of virtualized resources. Let's say virtual machine, virtual storage, and virtual network. So virtual machine in the sense we would be able to provide a basic virtual machine such as creation, suspension, okay, resumption, and termination. Similarly, for virtual storage, so this as an IaaS provider, okay, we will be able to provide basic virtual storage operations like space allocation, space release, data writing, data reading, expanding the drive size. Okay, all those things can be done. Virtual network, similarly, you can have a basic virtual network operations like IP address allocation to a VM. It could be dynamic or static, and domain name register, establishing connection, okay, and then bandwidth provisioning for each and every type of resource you require, what bandwidth you need. Coming to system monitoring interface. So here what you're going to monitor is you're going to monitor each and the state of each virtual machine on various parameters like CPU loading, memory utilization, IO loading, and internal network loading. So similarly, virtual storage has virtual space utilization. Everything is been clubbed and your space is allocated accordingly. So data duplication and storage device access bandwidth. Next is your virtual network. So you need to have virtual network bandwidth, multiple switches are grouped together and the consolidation would have happened. So network connectivity, load balancing, etc. So IaaS is a deployment platform. Okay, it's an abstract that abstract the infrastructure. Like you will not see what is underneath, okay, or below the infra. Above the infra only you will be able to know. So IaaS enabling techniques like you can see virtualization. They do server virtualization, storage virtualization, and network virtualization. And the services what they provide is they provide two services. One is resource management interface and system monitoring interface. Next is platform as a service. Okay, we will cover platform as a service and rest in the other services. It is simple. We will at least cover this alone. So platform as a service means consumer is can able to deploy okay consumer created or acquired applications. Okay, they want to using programming languages which is available the tools which is available in the, let's say, Google SDK. Okay, you can go and deploy or build applications on top of the development infrastructure. So the development infrastructure is given to you by the cloud infrastructure. So let's say the consumers, they do not manage, okay, the network server, whatever we saw previously. Like the IaaS layer will not be managed. They will be only working on the application, okay, and how to host it. So if you see Microsoft Windows Azure is one of the best thing. Like you can directly host your application on an app service. So now you can see the system architecture, like the computing, resource, network, and storage. Okay, all these things will go on IaaS. On top of that, runtime environment alone, it will give you like you can have scalability and elasticity. availability and reliability, performance optimization, and manageability, interoperability, like communication between different services. On top of that, you can see you can have programming IDE. Using that, you can build applications on cloud. So if you see runtime environment design, it refers to collection of software services available. Okay, like implemented by a collection of program libraries. Okay, these runtime have certain properties, let's say manageability and interoperability. Okay, so again, dynamic provisioning or see the control automation, system monitoring, and billing will come. Performance and optimization, you will have a what is it? You will have parallel processing, load balancing, job scheduling. So availability and reliability, you will have fault tolerant, resilience, and security. So scalability and elasticity is you will make allow dynamic provisioning of data or space and work on a multi-tenant design model. So service, so you provide programming IDE as service. So IDE is integrated development environment. So it will be integrated uh, with full functionalities, which supports underlying runtime environment, which we saw here. Yeah, all these things. So this ID is it will also provide some tools, okay, like profiler, debugger, and testing environment. So they will use a programming API supported from the runtime environment, so that using that various clouds, okay, they still have some operating functions, like they have some common operating functions like computation, storage, communication, communication, and resource operation. And coming to system control interface, like it has two things. One is policy-based control, and another one is work-based workflow control. Policy-based control means you'll be defining certain principle, okay, or rules to guide or take decisions so that you achieve outcomes accordingly. So certain places you will be having a decision, you will be making a decision based on some requirement. Workflow control means like a flow of installation, okay, how the resources are configured. Automatically, those things will be done. So workflow processing daemons, they will deliver the things on a faster way and efficient construction of management of cloud resources. So just a summary of the PaaS. So it is like abstract the infrastructure, the OS, and the middleware to drive. Previously, we saw only infrastructure. Now the OS is not under our control, and the middleware development environment is also not under control, which is taken care by the PaaS. So only thing is you will have enabling runtime environment and you will have APIs. Okay, software as a service we'll see in the next class, and now you can take up your quiz. I really know it is hard, like few classes, it will be like post that I will show some demos on how to access infrastructure, build applications on top of the cloud infra. Okay.